Hi students, welcome to Year 10 Science and the Motion and Energy topic. This is video number 4 on Newton's first law. So up till now we've kind of been describing motion in terms of some of those descriptors that we have, either how far an object has traveled, how fast it is moving, how long it's taken on its journey, and the rate at which its speed or velocity is changing. Well, what we want to try and do now is to understand how motion occurs. What is happening to an object or body that is causing any motion that it is experiencing or any change in motion. And we do that following Newton's 3 very important laws. These laws help us to describe, help us to quantify the types of motion that are occurring and any changes that are occurring in that motion. And the first of these that we want to just concentrate on for this particular video is Newton's first law. The important thing about Newton's first law is that we need a force to be applied to an object in order for that object to accelerate. Now, whilst this is more specifically tied to Newton's second law, it's a very important thing to understand if we're going to analyze the motion of objects and see how they fit in with Newton's first law. Effectively, Newton's first law is the law of zero net force. Now, I just want to contrast this with the fact that Newton's first law does not say that objects that are not changing have zero force acting on them. They may have 10 forces acting on them. The important thing about Newton's first law is that all of the forces, or any of the forces that are acting on an object, are in balance. They are cancelling one another out. So there is no net force. There's no overall force that's acting. And if we accept that the application of a force is needed for objects to accelerate, and force, which we've looked at previously, has the symbol F and is measured in units of newtons, then we need to apply this understanding of forces in order to analyze situations where there may or may not be one or more forces acting. Forces come in a lot of different forms, and we've used this sort of general definition of a force in the past. A force is a push or a pull acting on any object as a result of its interaction with another object. Sometimes forces are contact forces, like friction. Other times they are field forces, like gravity. So the object can be in contact with another object to experience a force, or it can actually just be in a sphere of influence. Now, the important thing about Newton is how incredibly talented he was. And the fact that when you contextualize all of these laws back to the late 17th, early 18th centuries, this is 300 years ago now. And so this was pretty advanced stuff for back then. Newton made huge contributions to science, and not just in the area of physics, but primarily in this area. And what's really important is the book he wrote, the Principia, and that was and remains one of the most important scientific works. And in it he outlined his laws of motion and also universal, the little hidden word here is universal gravitation. And these are things we may look at a little bit more in this topic, and certainly you will look at them in senior physics. So let's quickly just recap Newton's first law, or introduce it if you haven't heard it before or forgotten. The important thing with Newton's first law is that an object remains at rest, that is, its speed or velocity is zero, or in constant motion in a straight line unless acted upon by a net unbalanced force. And this is the key here. Multiple forces can act, but if they balance one another out, then there is no overall force. It's also known as the law of inertia. Inertia is a property of bodies that resist any changes in their motion. So as I mentioned before, if we have an object and we have two forces that are acting on this object and they are equal and opposite forces, then we have no net force. It's not that we have no force, just we have no net force, and therefore this object will remain in the same motion that it was before. There will be zero acceleration. As I mentioned, the Newton's first law can also be regarded as the law of inertia, which basically means that in our own experiences, any sudden changes of motion, quick starts or stops, such as when you're in a bus that takes off, if you're in a car that brakes suddenly, are more noticeable than if you're just traveling at a constant speed. This tendency of bodies to keep doing what they're doing is what we refer to as inertia, and it keeps moving objects moving at the same speed and stationary objects remaining at rest. And another important thing about inertia is the larger the mass, the greater the inertia. So the best way, of thinking about some of this is if you're a passenger in a car and you're not wearing a seatbelt, you can be seriously injured if the car comes to a sudden halt. We have so many different safety devices, which we'll look at later on, that try and overcome this whole idea of if there is no net force acting on you, you will continue in your motion. So if you're sitting in a car and it's traveling at 60 kilometers an hour and it's traveling in a certain direction, and the car comes to a sudden halt, you will continue to travel at 60 kilometers per hour unless some other force acts on you. Now, if it's an airbag or a seatbelt, it might slow you down slightly more slowly than if you hit the windscreen or the dashboard or something like that. This is an application of inertia, or the Newton's first law, and we'll certainly have a lot of different examples of that in class for you to have a look at. Thanks for watching.